the first for the academic year 2022-2023. Our first speaker today, our first speakers, I believe we have two, are Mr. Kemi Jones and Mrs. Cherran Weech O-Brien. Mr. Jones is an economic development specialist by profession with over 15 years of experience in the field. Currently, he serves as senior fiscal analyst in the Office of the Financial Secretary in the Ministry of Finance, focusing on research, design, development, and analysis of government economic and fiscal policy. Prior to his appointment, he served as program manager for the Over the Hill Community Development Partnership Initiative in the Office of the Prime Minister. This project was similarly designed to empower residents and businesses in the inner city community of New Providence via social and economic empowerment in a sustainable manner. He has and continues to serve in a senior role in many other transformative government initiatives and reforms, such as he is a member of the Economic Prosperity Technical Committee, which is a collaborative committee created to aid in driving the implementation of economic aspects of 2030 Sustainable Development Goal Agenda locally. Also a member of the Bahamas National Trade Policy Committee, which is a multi-stakeholder team created to aid in preparation of the country's first comprehensive national trade policy. He is a former member of the Bahamas National Development Plan. He is also a member of the steering committee for the creation of the Access Accelerator, which, as we know, is the Small Business Development Center. He's also a former member of the Bahamas Maritime Policy Implementation Committee. Mr. Jones' research has largely centered around the government policy and its impact on national development and growth. His research interests include the role of leadership in Bahamian special economic zones. It was published in the International Journal of Bahamian Studies in 2021. In 2020, his research focused on the impact of the 1992 investment policy reform on growth in the Bahamas, social and economic studies. Additionally, in 2020, he engaged in research under the topic, the role of technical and experiential learning in hurricane resilience in the Bahamas. His initial findings were presented at the UB Sustainable Grand Bahama Conference in 2020. And finally, the impact of development strategy choice on capital mobility and economic growth. And he did this with several other authors. And it is currently under review in the Journal of Development Studies. Mr. Jones has a passion for encouraging holistic development of businesses and communities. This drive has led him to become a member of the Rotary Club of Nassau Sunrise more than 2 years ago, where he has served in leadership roles in the club, serving as service committee co-chair, director, and club secretary. He is a Paul Harris Fellow and was a Rotary Club of Nassau Sunrise Rotarian of the Year for 2021-2022. Mr. Jones holds a Master's of Public Administration with a focus on national development from Peking University in Beijing, China, and a Bachelor of Arts degree in economics from Alacasta College in St. Paul's, Minnesota. He is also a graduate of the University of the Bahamas. He is a certified project management professional with the Project Management Institute, an experienced financial modeler, and has advised private companies and governments in over a dozen countries on a variety of economic and policy matters. Today, Mr. Jones shall speak to us along with Mrs. Cherran Weech O-Brien on the impact of shocks to the tourism sector on household consumption, evidence from the Bahamas. Mrs. Cherran Weech is a former director of economics at the Ministry of Finance and a former policy advisor for the governor of the Central Bank of the Bahamas. She has over 20 years' experience as an analytical and results-driven economist with local and international experience in economics and social development. She has experience working on a variety of qualitative and quantitative projects, including the provision of advice of an economic and financial nature to multilateral, bilateral, private, and government agencies in Latin America and the Caribbean. Currently, she is the principal consultant of EcoDev Advisors, a boutique advisory firm that helps decision makers identify and address circumstances that impact the economic and social well-being of humanity. Cherran's work at EcoDev assists by examining these issues and determining impacts on countries, sectors, communities, and households using a number of decision-making tools, including financial and economic impact modeling, survey design and implementation, statistical analysis, and market and econometric modeling. These tools provide quantitative and qualitative answers to support strategic directions that inform the development of economic and social policies. I invite you to join me as we welcome Mr. Jones and Mrs. Weech O-Brien to speak to us today on the impact of shocks to the tourism sector on household consumption, evidence from the Bahamas. Welcome.
Good day, and thank you, Jane Moxie. I must admit, I always get a bit nervous when you read my bio in such a manner, but thank you for such a warm welcome. If you permit me, I'll start sharing my screen right now. So my colleague, unfortunately, due to some logistical challenges, she also shares the same sign-in name as my name. So you'll see Kemi Jones twice in here, but she is indeed here with me. So as we begin, just in terms of how the presentation will flow. So as you can see, the topic that we're going to present about today is one that's very near and dear and significant to the Bahamas, looking at the impact of shocks to the tourism industry on household consumption. Household consumption itself being a proxy and a measure for the levels of poverty in the Bahamas. And given the significance of tourism to the Bahamian economy, we thought a very prudent topic to look at, particularly what's going on right now in the world, considering the rebound from the COVID pandemic, economically that is. So I'll pass on to Ms. O-Brien, who will begin with some of the literature review and overview, and then we will go into some of the actual preliminary findings from our research paper. So Ms. O-Brien.
Thank you. Thank you very much. Good afternoon, everyone. Mr. Jones and I have been discussing these sort of topics for a number of years now, which caused us to put our heads together to really begin to dig deep into this, to understand the real impacts on the livelihoods of people. So we can begin, Mr. Jones, if you can just, yeah. Thank you. So for an economy like the Bahamas, which is a tourism-led economy, we all know too well what an exogenous shock can actually do to an economy and to the livelihoods or households within our communities. So this topic, as I said, was extremely interesting to us, because usually when you look at these sorts of topics, you begin to look at it in terms of the financial impacts. What's often missing is a real good understanding of what's happening at the household level, what's happening with people's livelihoods once you have a shock like this to hit a tourism-led economy. So as Mr. Jones mentioned, we are using household consumption as a proxy for poverty when we look at these look at these matters. And as we know, the poverty levels that we're seeing based on the literature that we've reviewed, as well as some of the results that we're seeing, poverty levels are determined by the overall growth and resilience of an economy. And in our case, it would be a tourism-based economy. And the model that we use, and we'll go into more detail in a few slides, shows that a reduction in poverty takes place when your tourism output increases. So we'll begin to get into that in a slide or two. So to step back a little bit and actually talk about poverty, the link between poverty and growth is a very complex one. But when we speak about poverty, we're initially talking about the lack of access or money to have your basic needs met: food, shelter, clothing, those sorts of things. And what we've found is that even though a lot of the literature speaks to what happens in lower income countries or countries that are considered to be quote unquote poor, the statistics may be a little bit different in some cases with the middle to high income countries. It's more nuanced, the poverty there and what takes place, but it's still a factor that must be looked into in terms of the impact from a social as well as a fiscal impact on the country. And because of that, you've seen many leaders around the world, or many economies, begin to lean into the tourism industry a little bit more than they potentially have in the past. And a lot of that is because they have seen where tourism creates mass employment, it stimulates consumption, and it improves welfare. So it's seen to be a benefit for countries that take it on as their growth model. We've also seen that it can and has improved the lives of the poor in many ways. And that, of course, differs from country to country. But overall, we've seen that there are benefits to be gained from having the tourism, as a mainstay within an economy. The question then that we dug into a little bit is, what is the impact of shocks on consumption in countries who follow this model? So shocks here, we're talking about natural disasters, we're talking about earthquakes, tsunamis, things of that nature that are completely outside of the control of a country. Mr. Jones,
as we get into some of the literature, firstly, we thought it's prudent to look at some of the data that's going to be the foundation for our discussion. So what you see in this first slide here is actually data pulled from the Bahamas National Statistical Institute, the national accounts data for private consumption, being the consumption of individual households. And this data and analysis is also based on estimates of population to give us a proxy for private consumption per day, which would be equivalent to the measure that is used internationally for the poverty level, which would be $1 something per day per person. As we see, the Bahamas, of course, is well above that threshold, naturally, because we typically see the estimates of the Bahamas in terms of GDP per capita being much higher. So we would by no means be in that very low income distressed country. But what is also significant when we look at the data, we do see quite a bit of cyclicality in the data. The data is derived on a quarterly basis, since that's the level of disaggregation that's provided so far, quarterly estimates of consumption at the household level. And when we say consumption, this means things such as paying rent, buying groceries, electricity, all of those things that actually look at what's consumed on a daily basis, which is comparable to other countries. Of course, we do realize the challenges with our data. One, when we look at consumption, surprisingly, given the significance of tourism to our economy, we don't see data that's disaggregated to look at persons who are just in the tourism sector. However, if we assume ceteris paribus, all things being equal, and that capital is free to move in our economy from sector to sector, we would imagine that if the tourism sector is very profitable, persons would move from lower income areas to that sector. Hence the reason why we would have more than 50% of our economy being tourism-based. But we'll get to some of those details in a bit in mythology. But this just gives us an idea of the trends that we've been seeing historically in terms of the private consumption per person per day in our economy.
Okay, so just to look at some of the literature that we have reviewed in order to be able to wrap our minds around what this means for the Bahamas. We looked at Ivanoff and Webster, the 2011 paper, that used a number of different methodologies in order to be able to test what the impact is of the shock on consumption. So they used co-integration and Granger causality tests, cross-sectional tests, panel data, growth decomposition methodology. A number of things were used in order to be able to get to the root of exactly how this would affect consumption. These methodologies, in particular with this study, looked at about 174 countries, and they found that the tourism's contribution to economic growth to be higher in Africa, Asia, Latin America, and the Caribbean region. Some of this we already know naturally, but countries in Europe, North America, and Oceania saw a negative relationship. If we looked at what was happening in terms of the research in the South African communities, we found that the study indicated that the tourism exports, receipts, investments, economic freedom, enrollment to be positively correlated with economic growth. And when we looked at studies around tourism and poverty, we looked at the Khan study from 2020, which also applied a Granger causality test to time series data for GDP, FDI, energy development, agriculture, poverty, and tourism for Pakistan in particular. And they found that there was a benefit for households in terms of economic growth and a reduction in poverty when you have strong tourism value chains, you have an inclusive bottom-up value chain approach, and the backward linkages are in place and necessary for that benefit to actually be felt at the household level. Okay. So just to give a quick view of the methodology, again, a number of these studies outlined some of the equations that they would have used and we would have looked at as well in order to study this. So a number of relationships are examined here across the different equations. For the first equation, it speaks to a relationship between tourism and growth, where Y is the log of real output, X is the log of export, and represents the elasticity of outputs to exports. And another theory that would have come up in the literature proposes that when you increase allocation of resources to the tourism industry, whether it be financial resources, human resources, whatever level of resource it may be, it would result in increases in employment and income, increased exports, and just generally overall economic activity. Also, exploring the theory that economic growth uplifts all members of society and reduces poverty, or economic growth attempts to do so. We looked at the equation 3, where we looked at poverty levels and the change in poverty levels. We also looked at economic growth rate, and of course we applied an error term with this particular equation. The last equation here that we'll mention as far as methodology is concerned looks at the impact of tourism on poverty, which is dependent on the growth of other sectors of the economy, which is a very interesting discussion to have, because it really allows you to have that discussion about whether or not labor is able to transfer from the tourism industry into other industries should a shock actually happen, which is a method of resilience, or a way for people to be able to maintain their lifestyles. So this equation looked at the ability of the labor to shift when this type of shock is experienced. Okay. So the assumptions that we used throughout our discussions and our looking and analyzing the data, we've said this in different ways already, but the increases in tourism services results in overall economic output. We're assuming also that the increases in overall output are beneficial for all in society and reduces poverty. And as I just mentioned, the shock to the tourism industry may result in increased poverty over the medium term if labor is unable to shift from their tourism industry work to other industries in the interim or for the long term. So based on the economic theory and the review of the literature, the equation above is encompassing all of those thoughts and assumptions. We also used a natural logarithm of the quarterly observations. We use quarterly data from 2012 to 2020. As Kemi said, it's good to be able to see it on a quarterly basis. We're able to see the seasonality. And so we used that method to conduct the analysis. We added also a dummy variable to account for the negative tourism output shock, such as COVID or hurricanes.
So in terms of the results, while the data and our analysis is still preliminary, there was some interesting findings already. So just in terms of the full model specification, so far we've applied several different approaches. I'm just showing one right now would be the regular OLS regression. And of course, as O-Brien mentioned, we did use a dummy variable, and it's lagged by at least 2 quarters. So that helps to alleviate concerns such as dealing with things such as multicollinearity and endogeneity in the model. And we did do tests for stationarity and other issues, et cetera, in the model. But just high level, we see the initial results are a fairly decent R-squared with a result of 0.59, which gives a fairly decent correlation and fit for the model. But in terms of the results, naturally, when we look at the p-values and the coefficient for the growth and output, naturally, as the economy itself grows, all things being equal, we expect an uplift in consumption for everyone in the country, and this is corroborated by the results. More interestingly, we find we look at the variable for tourism as a share of GDP in terms of tourism output as a share of the total economic output, we see a negative correlation. While we're still doing some investigation on this in terms of the specification, we do see the p-value is significant in this case. And this could speak to things such as the crowding out in the tourism sector, crowding out employment, and the possibility of stickiness, meaning that when a shock does happen, because persons are embedded in that sector, there's difficulty moving elsewhere and limiting your ability to maintain a stable level of consumption or income. But more importantly, what we look at and we find, and for the growth aspect, we see that the coefficient and the p-value is significant at the 1% level. For the tourism as a share of total output is significant at the 5% level. But more interestingly, when we look at the dummy variable, the one that's going to be an indicator of the shock to an economy, we see that it's significant at the 10% level. It is negative, indicating that when there's a shock, there is a decline in consumption. But we also see that the variable is very, very small in terms of the coefficient. But that's not surprising, because when we look at things such as the vulnerability and as actually look at the variation in the quarterly data, we see that there's quite a bit of variation at the consumption level, partly because when we also look at the savings level, it's not significant, meaning that persons have very little resources there. So you're already in a sector that's very vulnerable and already exposed. When there is a shock in terms of your vulnerability, that shock really doesn't present much more disadvantage to you. Is my best and our best interpretation of the results here. You're already very vulnerable in a very highly susceptible sector to things such as hurricanes and any other natural causes. And as we've experienced recently, the issues surrounding COVID that can propose a shock to the economy, even other external factors such a downturn in the U.S. economy, which is our major source market. All of those factors cause us to already be faced with a very vulnerable sector that's exposed to another shock, which, to be honest, in this case, is not presenting us, making us at any much more of a disadvantage. Looking at some of the other findings and results, such as the causality test, the major causality test, which gives us an idea of the direction of causality. And surprisingly and interestingly, in this case, this test does corroborate some of our findings. Most significantly in this case here, the question, the null hypothesis being does changes in tourism output, it does not cause a change in consumption. That's the null hypothesis, and as we can see from the p-value here, we can throw that null hypothesis, implying that a change in tourism output, it necessarily does going to cause a change in consumption level. And the same thing happens as the tourism as a share of total output. It does necessarily Granger cause a change in actual private sector or household consumption. That being said, there are certain data gaps. I think the most prudent one for me would be surprisingly that we don't have disaggregated levels of data, particularly for consumption of persons in the tourism sector. While we carefully monitor data such as FDI receipts, we carefully monitor tourism spending, we monitor those aspects of it, but I see very little attention has been paid in terms of data gathering to the other side, being the social implications of this very, very important industry to the Bahamian economy. Ms. O-Brien?
Yeah, just to add to that, in terms of the data gaps, it's also important for us to be able to understand poverty better than we do in the country as well, because if it is that these significant shocks that happen to the economy, and mainly to people who are in a very vulnerable industry, like Mr. Jones said, where things can be shut down almost overnight, it's important for us to understand exactly how close they are to the poverty line in order to be able to build some sort of program or policy to be able to provide some measure of support. And of course, that would have fiscal implications like we would have seen after Hurricane Dorian and COVID, where the government would have stepped in and obtained some borrowing in order to be able to provide social support. So without having that data, the last data I think that we have for poverty is from 2013, which would have been before Dorian and before COVID, would be somewhat unreliable. So it's important for us to be able to really understand exactly where we are in terms of poverty. And the census taking place now will help with that. And hopefully the household expenditure survey will be forthcoming. It usually comes after the census. And that is really the expenditure survey. It's a very in-depth expenditure survey that would really be able to help us get into the details of not only the poverty line, but who is poor, and look at it from different segments of society. Is it female-headed households or male-headed households that are more poor than others? So all of those types of dynamics and details would really go a long way in terms of really understanding what a shock to our main industry could mean at the household level.
But despite those limitations, I think we still do at this point think that the work we've been able to undertake thus far is very, very meaningful, and it does contribute quite a bit to us better understanding the issues of poverty and how do we address those concerns within our country. And with that, I would thank you for listening to our presentation, and I would leave it up to the moderator to indicate how many questions we can entertain at this time.
Thank you.
Thank you both very much. We'll entertain 2 questions. You can put your questions in the chat.
Is there any way we can get a copy of the video from the recording?
Yes, the video will be sent out to all persons in the space, in the Zoom room. Are there any other questions? Questions, comments? Well, Mrs. Weech and Mr. Jones, Weech O-Brien, I'm sorry, and Mr. Jones, thank you both so very much for your very informative presentation. Undoubtedly, you've done an excellent job because there are no questions. Not often that you engage a presentation and there are absolutely no questions. So thank you both very much for your presentations and for kicking off the Research Edge Forum 2022-2023 academic year. We are grateful to both of you.
Thank you.
Thank you very much for the opportunity. Unfortunately, I have to leave for another meeting, but if there are any other questions, since some faculty, students, and colleagues know how to reach me.
Thank you. They do.
Thank you very much. Thank you.
You're very welcome. Thank you both. Our second speaker today is certainly no stranger to the university. He is Dr. Amin Kabir. He has been working as an assistant professor of physics at the University of the Bahamas since August of 2013. Dr. Kabir obtained his Bachelor of Science in Physics from the University of Dhaka in Bangladesh in 2000. He earned his Master's of Science in Physics in 2005 and a PhD in Physics in 2010 from the University of Cincinnati in the United States. He has been awarded university graduate scholarships at the University of Cincinnati from 2003 to 2010. He received the Faculty Excellence in Teaching Award in 2018 and also the Stanley Wilson Award for Research Excellence in 2021 at UB. Dr. Kabir conducted his research works in the area of nonlinear optics and
photoelectric effect.
You know, that's beyond me, Dr. Kabir. I am a
Right. That's
business
all right.
major. My apologies.
That's all right.
In semiconductor nanostructures. During the PhD program, he has had an excellent opportunity to teach undergraduate recitation classes in cooperative learning formats. He was inspired by the effectiveness of these interactive teaching methods and in fact became passionate in teaching physics. He has been nominated by the Physics Department of the University of Cincinnati for the Excellence in Teaching Award in 2010. After his PhD, Dr. Kabir worked as a postdoctoral researcher in the terahertz spectroscopy group at the University of Alberta, Canada, from 2010 to 2012. He worked extensively on crude oil optical properties using it, time, dominion, spectroscopy in collaboration with Schlumberger Oil Company in Alberta in Alberta. In 2012, he joined ultrafast spectroscopy group at the McGill University as a postdoctoral fellow and worked on coherent multidimensional spectroscopy in nanostructure samples until he joined UB as an assistant professor in 2013. He has presented his research works in many international scientific conferences and published articles in high-impact scientific journals. Dr. Kabir constantly works on the development of physics lecture and laboratory classes at UB. In collaboration with Central Connecticut State University and
NOAA.
NOAA Global
ESRL, yeah.
ESRL Global Monitoring Division, he has established an optical atmospheric research project at UB conducting aerosol studies and their dynamics impacting air pollution, precipitation patterns, and climate change regionally and globally. Dr. Kabir has received UB research grants for this project and additional grants for students who work as research assistants under his supervision. Today, Dr. Kabir will speak to us on monitoring Saharan dust transport over Nassau using a laser and a CCD imager. Please join me as we welcome a well-researched Dr. Amin Kabir.
Thank you, Dr. Moxie. And thank you all for your attendance. I hope you all are doing great. So today I'm going to talk about our research finding to monitoring Saharan dust transport over Nassau using a remote sensing technique in which we have used a laser and a CCD camera. This is one of the research findings from the project that I started developing in 2015. I should give a little bit of background that how I developed that research project at UB. So I met Professor Nimi Sharma from Central Connecticut State University in an international conference which was held at UB. I was very much interested about her research, seeing the potential application in the Bahamas And also the research didn't need an expensive electronic devices or instrumentation. So I discussed with him about a potential collaboration, and she introduced me with a research scientist from NOAA, ESRL Global Monitoring Laboratory, who is Dr. John Burns. So he gave me the technical details about this project, and I wrote a proposal seeking for fund from UB internal grant, and many thanks to UB research office for approving the grant. So I started developing since 2016. It took me a year to get all the instrumentation in hand and optimize those instrumentation and setting up the project. So I should also thank Dr. McNamara, Dr. Watson, Dr. Oriaki, Dr. Linda Davis, Philip Armbruster, and many of my colleagues and staffs, UB staffs, for supporting me and encouraging me to continue the research for the past several years. So I continued to get more research funds to continue this project. Of course, the students, many students worked under this project for the several years. And without their help and dedication, I could not and will not be able to continue this project. So in 2020, just in the early pandemic, during June, there was a huge dust transport that originated from Saharan Desert, crossing the Atlantic in the early June, and then it was crossing over Nassau and ultimately going to USA in the late June. So that dust was not that much thick. We could not see during that time by bare eye, but I was very interested to see what about the technique, that remote sensing technique or instrumentation that we have. Can we detect that transport and the structures, the layers that changed in the atmosphere of Bahamas? But the challenge was it was the early pandemic and everything was locked down, and there was curfew at night, and our experimentation was conducted at night. So I had to take a special permission from UB security to stay overnight for 2 nights at UB and conduct those experiments. Many thanks to Dr. Odiambo, who assisted me and agreed to give me hand on the experiments that was conducted at night. So he also stayed overnight for two nights at UB for taking data with me. So the technique, the remote sensing technique that we use is called CCD camera-based imaging LiDAR setup. So LiDAR is a technique, a remote sensing technique, whose acronym is light imaging and light detection and ranging. For us, we call it C-LiDAR or CLiDAR, which is a camera-based light detection and ranging. So this is called CLiDAR by John Burns Group, and it's also sometimes called CCD Labs, which is Laser Aerosol Detective System by Yuan Ban Group in Peking, China. So what we do is we transmit a vertical laser up into the sky from a ground-based laser source. CCD camera, which is fitted with a fisheye lens, is separated a d distance away from the laser source. Because it is fitted with the fisheye lens, it can capture the entire laser beam from ground to all the way to the zenith without tilting the camera or without the need for scanning. So what it means that we can get the full signal from the ground to all the way to the zenith at once in one shot. Now, the scattering angle depends on the altitude, and for this setup, that scattering angle of the particles is 180 degree at the zenith, and it becomes 90 degree at the at the ground. The resolution is called DZ, and that changes with the altitude Z. For the setup, the resolution is much better at the lower, the ground state or lower altitude, but it gets worse when it reaches to infinity. The CCD pixel view is constant, and that's why the altitude gets better with decreasing altitude. So what our instrument measure is a side scattering of the particles, of the aerosols, of the particulate matters that are present in the atmosphere. And since the laser was passing through, those are scattered. The light are scattered from those particles, and those scattered light is collected by the CCD camera. Since we are interested that from which altitude those particles, the scattering are coming, we need to measure how much is that altitude for that particulate scattering. So we do it by simply using the geometry. Unlike the traditional LiDAR, actually they use expensive electronics. Usually traditional LiDARs are very expensive, around $100,000. The setup that we use, it is about $10,000. So I actually received $10,000 grant when I wrote the proposal at the first time. So for us, we really don't need to have any time information to calculate Z using expensive electronics. Now, since the atmosphere contains molecules, which is composed of nitrogen and oxygen, and it also composed of dust particles, particulate matters, we need to separate those molecular signal. Then we have an idea how much is that dust particles or particulates are present in the atmosphere at different altitude. The molecular signal can be obtained by knowing the molecular density at different altitude, which can be found by knowing the pressure and the temperature by radiosonde data. The molecular signal is basically obtained from the Rayleigh scattering model, which is a function of molecular density and scattering angle. For our setup, the scattering angle changes from 90 degrees to 180 degrees. As seen from the signal, it has a smaller change in the signal in the 3 order of magnitude, which facilitates the detectors to have linear response for the entire range. So this is a useful property because if the range of the signal is too high, then the linearity doesn't remain, and then we don't have any idea that how much is the particulate matters present in the atmosphere. Now, another good thing about the setup is since the laser and camera are separated, so there is not a geometrical overlap issue that enables us to get the signals all the way to the ground. So which the traditional monostatic LiDAR cannot do because their detector and the transmitter stays at the same place. Now, it doesn't mean that our system is better than those. We can think of a complementary system because for traditional LiDAR, which are very expensive, they're excellent in the high altitude to achieve the high altitude signals. But for us, it can get nice signals from very high altitude, but not as much with the resolution as the traditional LiDAR, but we can really get very nice resolution signal at the ground level. So this is a sample image, CCD image of the laser beam that we took in a night sky. We used a 3-watt continuous wave laser at 532 nanometer. This is a class 4 very dangerous laser. We use transmission filter at 532 nanometer to reduce any background noise. We have kept the camera to laser distance around 90 meters. We have done this experiment at the back of the SIS building. And the CCD exposure time to take the images was around 120 second and 30 second. So this is the image basically we do for the image data analysis. because this signal, this CCD signal contains the background, molecular side scattering, and also any particulate or aerosol side scattering. So we can see that the images was actually tilted. The camera was tilted because we would like to utilize, maximize the space of the CCD pixel in the camera. So the lower part of that image is the ground, and the top part is approaching the zenith in the sky. Now to analyze the pixel counts, we had to fit the beam center with a polynomial. Then we need to find the perpendicular of that polynomial curve. Then we interpolated pixels along perpendicular to fill the fitting array and fit array with a Gaussian plus a constant function. And the signal was simply the area under the Gaussian curve. Now, since we got just the signal from one scattering angle, so how we really separate that signal, that aerosol signal? To do that, we have done a signal intensity at each altitude, which is being plotted. Then signal intensity at a region free of aerosols was normalized to a model of molecular scattering. The purpose of that is to remove the molecular part and to get the aerosol scattering. So the molecular scattering was subtracted, and we have obtained the aerosol single angle side scattering, which means this is the scattering coming only in one angle. But like all other traditional LiDAR system, like the remote sensing of aerosols by traditional monostatic LiDAR methods, our system also requires phase function to convert single angle scatter to total scatter. So what it means that light scattering depends on the angles, and we need to have a clear idea that how much scattering is happening in one direction compared to the all 360-degree angle. And for that, we need to have a knowledge of the aerosol phase functions. So there are already available models of the aerosol phase function. We have used the polluted continental phase function to find the total scatter. Because we are getting single scatter, we need to have the information how scattering is happening in all 360 degrees. So we have used that aerosol phase function to convert the single scatter to total scatter. And ultimately, we needed to use single scattering albedo, which is actually the ratio of the absorption and the total incident light to find the aerosol extinction. So that is an optical property that is widely used in the environmental scientists, by the environmental scientists. After we did all those kind of analysis, this is our ultimate result that is plotted as a function of altitude and extinction. So this is the aerosol profiles, meaning that how the aerosols are distributed over time and space along the altitude for 3 different days. So one of the days was in February, which is the day when the Saharan dust was not passing over the over Nassau. Now that is given by the gray line and gray plot. So that's a very typical aerosol profile that I have seen in last 4 or 5 years. However, the orange one and the green one, that aerosol extinction as a function of altitude, are done in June 2020, which is around the time when the Saharan dust was passing over the over Nassau, over the Bahamas. We can see a clear difference between the aerosol profile from February to the June data. So if we see a little bit closely with the data, aerosol layers with high extinction on June data is observed between 2,000 meters to 5,000 meters. A thick layer is observed. In June 29, we also see there is a thick layer of aerosol or dust particles from 0.9 to 1.6 kilometer. And also from 2 to 3 kilometer, there is another thick layer from aerosol extinction is observed. So these thick layers of aerosols above 1 kilometer altitude in the June data coincide with the passing Saharan dust that I have shown before by NASA's GEOS model, and which agrees with NASA GEOS 5 model. So we can fairly say that the thick layer that we are seeing from our instrumentation is basically the Saharan dust that was passing over the Bahamas. Also, the heights at which those dusts are detected by our remote sensing method falls within the altitude range of Saharan air layers that are typically found by the scientists over the years in the range of 1.5 to 4.5 kilometers above sea level. These findings I have presented recently in Optical Sensors and Sensing Congress 2020, which was held in Vancouver, Canada. So this is just to show that NASA's animation model showed there is Saharan dust transport at local time 9 p.m. on June 27, which is actually UTC time 1Z on 28th June 2020. So we can clearly see there was a presence of Saharan dust at that time. This is the Saharan dust transport from the model at local time 11 p.m. On 29th June 2020, or the UTC time of 3Z on 30th June. We have done this experiment starting from 8 at p.m. and then probably at 1 in the morning next day. So I have plotted all those in a contour plot to show how the structures, the layers are changing over time as a function of altitude. So that's there are two contour plots for two different dates. One is on 28th June 2020, another is on 30th June 2020 UTC time. So clearly you have seen that on those dates for around 0.1 hour to 5.5 hour UTC time, there is a thick layer of dust particles at high altitude, starting from 1.9 kilometer to almost 4 kilometer, which is very unusual on other days of the experiments that I have done in past few years. Here also on 30th June, profile, we have seen a very thick with a high extinction between 1.2 to almost 2 kilometers. Again, that is not very normal aerosol layers or particulate layers at that altitude on any other day. To confirm that those are actually Saharan dust, we have also done back trajectories, which is which can be obtained in NOAA high split model. So what we have done is, okay, we have gone at a particular altitude where we have a high aerosol thickness, and then we went backward for almost 2 weeks to see where those dust are coming from. So as it is seen that those back trajectory shows as those particulate matters or the dust particles were indeed originated from the north of Africa for these back trajectories at 2.3 kilometer above sea level on 28th June. We have done another back trajectory for other day, which was clearly shown that the dust particles that were passing over Nassau were indeed originated from the north of Africa, from from Saharan Desert. For our further investigation, we wanted to see the satellite data. So we used MODIS Aqua satellite on Bahamas on 28th June during Saharan Dust Transports over Nassau, which shows us the high aerosol optical depth, which is basically the integrated extinction over the vertical column on Nassau atmosphere, which shows an AOD of 0.35 on 28th June. The aerosol optical depth on the other day, on 30th June, also shows 0.35. No, those are not the typical value. We don't have that high aerosol optical depth on any other day. Usually, the aerosol optical depth are around 0.1 to 0.15 on any other day in Nassau. Which is shown here that NASA's MODIS Aqua satellite shows aerosol optical depth over Nassau is around 0.15 on 21st February 2020. So our future work, that's my plan at this point, is measure aerosol optical depth by ourselves and compare it with the satellite data. And also, since we are using the model aerosol phase function to calculate aerosol extinction, so that might vary or bias our results. And we want to eliminate that uncertainty as much as possible. So we'd also like to find aerosol phase function by ourselves, then we can incorporate that one to calculate extinction. So the goal is measure seasonal aerosol profiles in Nassau and in other islands, which I have already actually measured. I have been in San Salvador, have taken the data, and I actually presented that one in my last research edge. And then would like to find the aerosol phase function by using 2 camera instead of 1 camera. So that can give us more information and aerosol phase function. As I said, you'd like to also find aerosol optical depth using star photometry. The work is in progress. I have already found star photometry, found some results using the star photometry. And from Nassau and in central Connecticut state atmosphere, because they have sent me some pictures which I analyzed. So what we have done, aerosol layers, which are suggestive of Saharan dust and aerosol profiles all the way to the ground by using a continuous wave laser and CCD Imager, which is a remote sensing technique. Because of the biostatic nature, or because of the separation of the camera and the transmitter, there is no need for timing device. So we get also excellent resolution at the ground levels. Our technique can measure the aerosol single angle side scatter, and using the model aerosol phase function, we can find the total scatter and aerosol extinction. However, we need to use our own phase function that will remove the uncertainty a lot. And finally, we would like to find our the aerosol optical depth, which is another important parameter for the climatologists and environmental scientists. Of course, interested students are welcome to join our research group. As I said, for the past few years, a lot of undergrad students work in the group. They gained an excellent research experience that enriched their CV, and it helped them finding admission in international universities. That's all from my side, and thank you for your attention. Questions are welcome.
Thank you very much, Dr. Kabir. Very informative presentation, Do we have any questions? Are there any questions for Dr. Kabir? Please ask your questions.
I've got a question, please, if possible.
Go ahead.
Mark Stevens. Thank you, Dr. Kabir. That was really interesting. I just caught the last part, and I know that this dust, when it blows into the Americas in the tropics, it helps to fertilize the rainforests.
Okay.
But I can see your profiles are quite high in the atmosphere. But does any of the dust, actually land on the Bahamas and help to fertilize the soils?
Yeah, I actually did some research on that, went for literature review. I have seen that because this is a kind of a seasonal a phenomena. It didn't really happen in that year. It usually happens in every year, but not in that scale. And as I was reading, I saw that yes, indeed, some dust particulates had a chance to land on the Bahamas soil. Usually, those dust particles are very thin, but if there is any rain or high humidity at that time, then they have possibility to land on the Bahamas. And as I said, yes, I have seen in some literature, Bahamas soil have been enriched, not maybe at that quite high amount, but at some some level that have been enriched by that dust particulate matters.
Yeah, and just to follow on from that, in the East Bahamas, they actually have red soils. Like when I visited Cat Island, the soils are red there, much more than on New Providence, and it's probably related to that.
Yes, because this is just not 1 year, right? It's happening every year, and there is a possibility that had been enriched by the dust particulate matters, which is landed. Because, as I said, usually because they are at the high level, they really transport without falling down unless there is a rain or like high humidity.
Thank you.
Dr. Cartwright? Kenneth Cartwright, you may ask your question.
Thank you. Actually, the question I had is pretty much the same question that Mark Stevens had. Okay. Why should we care? Why should we care about how much dust is in the atmosphere over the Bahamas?
Oh, that's interesting. So why should we care is because interestingly, this especially this Saharan dust has an interesting impact on the storm. As we know that scientists say that there is a storm forming, is becoming dangerous, but interestingly, Saharan dust help reduce the storm.
Interesting.
Yeah, that's interesting. I don't know honestly what's the phenomena, what's that, but they are not all bad. As you say that those dust particles can enrich, and they can also help reduce the storm. And you said why we do care, because of this, all those kind of an important effect that is really changing the having an influence on the climate. This is why we all want to know how much dust particulates are in there, because that they can really change the precipitation, the cloud formation, and all sort of climatology are affected by the amount of particulate matters in the atmosphere.
Interesting. Dr. Curling, and then Brown, and then Eugene Brown.
Yes, good afternoon. Excellent research, Kabir, particularly on such a low budget.
Yes, that's the reason I was interested.
Yeah, it's very good. I was wondering though, is this, I only recently heard, pardon my ignorance, I only recently heard about the Saharan dust, in the recent years when, hurricanes were coming so frequently. And the weather report started commenting on the fact that, certain various depressions are not going to form into full hurricanes because of the presence of Saharan dust, as you mentioned. It might be something to do with the shear forces in the air.
Right.
But is this a new phenomenon or because of activity over in the east? Or has this always been going on? Oh, do you know if this has always been going on throughout the centuries and we just found a way to detect it?
Excellent
Maybe
question.
Professor Stevens can also jump in on the conversation with him since it's in his area.
Right. So it's not, as I say, the Saharan dust has been there for many years. I think the first time it was detected in 1970s. I don't exactly remember, but it is in that decade. One of the professor from Florida, I'm not sure, Florida University or one of the, he's an excellent climatologist. His name is Dr. Prospero. He is the guy who basically detected that Saharan dust. So it's been there for many years, but it's been in conversation for the recent years because of well, probably more people are interested in the climatology, and they wanted to see is what are the phenomena are affecting our climate and forming storms, because it's a frequently happening, these storms, and I think the intensity of the storms also are rising. So that's why it's probably this Saharan dust is in focus nowadays.
Regine Brown.
Hey, good day. Nice presentation, doctor. My question is, would you say the Sahara dust is more present in our atmosphere during the summer months compared to other months? And if so, why?
It is big. Okay, so I'm not an expert on that one, because this is originated from the Saharan desert. Now that has to do something with the temperature and the local, is because it's basically coming from the sands, and the sandstorm probably are happening during the summer. So there is I think meridional wind, like easterly wind, that kind of takes the sands up in the sky, I mean up in the atmosphere during that June or July time, and then because of the easterly wind, they kind of transport in the west part. But as I said, it is definitely due to some sort of an environmental effect, like temperature, humidity during those months. That's why they are basically in those during that time of year.
Okay, thank you.
Mm-hmm.
Are there any further questions for Dr. Kabir?
Good afternoon.
Okay.
Yeah, I have one.
Oh, yeah.
It's
Go ahead.
Arturo.
Arturo,
Good
yeah.
afternoon.
Oh,
It's
how are
Arturo
you?
Hutchinson.
All right, yeah.
Okay, yeah, I noticed that this year, the early part, usually around when the hurricane season starts, we had a lot of Saharan desert clouds passing over us, and not until the clouds cease, the dust cease, then we start getting a lot of storms coming our way. That's something that I have noticed. I don't know if you're looking at that.
Yeah, as I say, there are like some direct effect of Saharan dust with the storm formation, but as I said, I don't know exactly the right phenomena on that one, but I know the scientists are really working on that one. So at this point, I really cannot answer your question.
Yeah, I'm just saying that's just something that I've noticed. I don't know, somebody could do some research on it, but the more dust that we have coming our way, the less storms, or the storms will start at a later date. Because you notice that our storms this year really started late. So that's something that someone could actually look at.
Yes, of course, yeah, because of this storm and those things, a lot of scientists are interested to know all the factors mainly. Just
thanks.
one thing, I see Dr. Odhiambo wrote some in the chat that red soils in the Bahamas are the input from Sahara dust from the in North America over hundreds of thousands of years. So it's been going on thousands of years, but I don't know much about that one. But as I said, I read about that. It's been going on, and they are enriching the soils. So Dr. Odhiambo probably would be a good person to know more about that. Yes.
Excuse me, can you hear me, Dr. Kabir?
Yeah, Dr. Gesmia.
Yeah, I have a question about the models. Are you using some mathematical models like transport equation or Boltzmann equation to model this phenomena?
Well, look here. The back trajectory models that I have used, that's not by me. It is NASA's model. Those who have all those, I mean, they have taken care of all the wind and precipitation and humidity model. That I haven't done that, but the model that I have done is the molecular model. So there is no transportation model there. It's basically based on the ideal gas law. Which can give us the pressure and temperature. I mean, if we know the pressure and temperature in the atmosphere, then we can model the molecular model that can give us the information with the altitude. But no transport. No, I haven't used that.
Okay, thank you.
Hi, Dr. Kabir. Can you hear me?
Yes, I can hear you.
Mr. Dogan, thanks for your nice presentation. Just, I think your project is based on the air pollution, aerosol behaviors, right?
Right.
Just I worry about the images. For example, you get images like its depth becomes from 1,500 kilometers up to 4.5, right? Around. Okay, after getting this image, in your project, do you have any idea? For example, when you investigate the air pollution, what particles over there, or in this dust, what types of particles? It is harmful or for the human health? Do you have any such facility in your project or in your investigations?
Right, very good question. Of course, that's one of the interests, right? First of all, with this remote sensing, what I get the total scatter from all particles, ranging from all sizes, like several microns to few hundred microns. Now we all know that is basically the 2.5 micron particulate matters, and less than those are harmful for the health usually. This instrumentation cannot give us that particular size, but it can give the total of those. Now I have actually few sensors that are placed at UB at two places. One is in the T block, another is in the South Security Gate. They can give us the measurement on those size dependent particulate matter. And I have also that research actually. If I get some time, maybe in next research page, I can show that.
Okay, yes. We can discuss. Okay, thank you.
And also, Dr. Hopefully I started working with Dr. Odhiambo. He is an expert on those, and hopefully we'll have some collaborative research with him very soon.
Okay, thank you.
Dr. Kabir, this is
yes,
Dr. Conrad again.
Yes.
The thing I'm still confused about is your method is a new method.
It's not a new method, Dr. Cartwright. It was invented in 2003. Okay. By one of the research scientists in NOAA, National Oceanic and Atmospheric Administration. He is the guy who I was in contact with, and he helped us with all the technical details that I needed to start my project here. And they are, yes, they are helping.
Okay.
Me. So it is invented by him, and then he taught also some professors in China. So there are 3 or 4 groups now that are working on this method.
So my question was then, if this is a new method, how confident we are that we get results that are consistent with the more expensive method?
Yeah, as I said, it's an excellent question, Dr. Cartwright. Our system is very good at the low level ground state,
right?
Lower level, because it has a good resolution. As it goes up and up, the resolution gets smaller and smaller, which means we are not confident if we go, suppose, beyond 5 kilometers. So then it has a large resolution. We don't know from which height we are getting that information. Like will be so it's good. Now, how confident we are? This is why we have some other ground-based instrumentation, like some other instrumentation that can measure those particulate matters at the ground level. So we can always compare our measurement with those ground-based thing that I started working with Dr. Odiamba actually now. So this is one thing. Another thing, it's already been done by using another sophisticated instrument, which is called nephelometer. So it is being verified that the ground level or up to 2 kilometers or 3 kilometers, this instrumentation is an excellent method to extract that particulate matter. But above that to like 5 kilometers, I think clearly it is the traditional LiDAR method that expensive LiDAR methods are excellent.
Okay, thank you.
Are there any further questions for Dr. Kabir? Colleagues, and guests, I think all of you would agree when I say that today we started off the Research Edge 2022-2023 with 2 very informative presentations. And for that, we are indeed grateful to Mr. Kemi Jones and Mrs. Cherran Weech and Dr. Amin Kabir. I say thank you all very much for your presence in the Zoom space, for your questions, and to the presenters for very, very informative presentations. Have a beautiful weekend, be safe, and be good to yourselves.
Thank you. Thank you for
Thank you.
You're welcome. See you
Thank
next
you.
time.